Hi students, this is Mrs. Laybourne and these will be the notes for 10.3 and 10.4. So 10.3 talks about other ways to solve quadratic equations. So far we've talked in the last chapter about graphing and, in the last chapter we talked about factoring the polynomial and then using the zero product property and finding the zeros of the function, or using the zero product property, finding the values for x. This method is going to be graphing, and the standard form, for a quadratic equation and I'll abbreviate equation, where again a is not equal to 0, is ax squared plus bx plus c equals 0. So to solve a quadratic equation by graphing, we want to first make sure the equation is equal to 0. We're going to find the vertex, the axis of symmetry, and make our table. Then we're going to graph the parabola, and then we're going to find the x-intercepts of the graph. So for this first example, I have x squared minus 4x minus 5 equals 0. So my equation is equal to 0, so I have that step completed. And now for my vertex. Well, I need to calculate minus b over 2a. So before we do that, let's say what a, b, and c are equal to, so we have that information handy. So a is 1, the coefficient of the x squared term. B is negative 4, the coefficient of the linear term. And c is negative 5, it's our constant. So the opposite of b over 2a would be 4 over 2, which is 2. So our vertex is going to be 2 for x, and now if we plug in 2 for the x values, we have 2 squared, or 4, minus 4 times 2, 8. So now we're at negative 4, and then minus 5, and we get the y value to be negative 9. Or we get our equation, I guess I should say, equal to negative 9, so that we can graph it. The axis of symmetry is going to be the line where x is equal to 2. So far we have the point 2, negative 9 as our vertex, and we have this line as our axis of symmetry. And again, that's where x is equal to 2. So now we can make our table. And I'm going to ask you to press pause and make the table and draw the graph, and then come back and check your work with mine. So the vertex is here in the center, 2, negative 9. My other values I used are 4 and 5, and then 0 and negative 1. And my y values were 0, negative 5. We already had negative 9, negative 5, and 0. If I graph them, so there's my 4, negative 5. Here's my 5, 0. And now I have 0, negative 5, and I have negative 1, 0. And so if I try to draw my parabola, it's looking something like this. And again, remember, we want to use our entire coordinate plane. So there's the graph. And as we said, we want to find the x-intercepts. Sometimes they will be points that you have found for your table. Other times they will not be that situation. But right here we have our x-intercepts, and they would be the x-intercepts are -1 and 5. And so our solutions for x would be -1 and 5. If you were to solve this equation by factoring, you'd know that the factors of x squared minus 4x minus 5, this is x, and we'd have -5 and +1 equal to 0. And our good friend tells us that either x minus 5 equals 0 or x plus 1 equals 0, and we get x to be 5 or -1. So we're getting the same answer, it's just a different way. And what's neat about this chapter is that it shows you many ways to solve a quadratic equation. And some equations are best suited for a particular method, and other ones we have a variety of methods that we can use, and each of them would allow us to get the answer at about the same rate. Okay, so another thing we need to think about too is that, remember that if we have a function, then the zeros of the function are the x-intercepts. So that means again that you're letting, if we had f of x equal to x squared minus 4x minus 5, to find the zeros of the function, we would have replaced f of x with 0. And now we'd have the same equation that again we could factor or we could graph. We want to keep in mind that when we draw our graph, so if this is my coordinate plane, and I'm going to do 3 of them real quick because I want to change the color so the graphs will stand out a little more for you. And here's my third one because I'm going to have 3 situations. And so if my graph, whoa, I lost one of my axes here. Okay, let's try to get that back again. Okay, and if my graph looked like this, and it went back to green, then I'm going to have 2 x-intercepts, and so I have 2 solutions. It disappeared again, didn't it? Okay, if I have, my graph looks like this instead, and it just has this one x-intercept right there, then I'm going to have only one solution. And if my graph is, let's say like this, it never touches the x-axis, and so I'm going to have no real solutions. Okay, let's go on to section 10.4, which now is going to talk about another method, and that is to solve quadratic equations using square roots. So we can use this method, using square roots, to solve the equation if our quadratic equation is of this type. So you notice right away that there's no bx term, which means that b is going to be equal to 0. So if we have that kind of situation, then we might be able to solve it using square roots. Okay, so my first example is to solve 3x squared minus 27 equal to 0. So we first want to isolate the x squared term. So I'm going to say isolate x squared term, and my pen's getting a little messy, so I apologize for that. So I have 3x squared equal to 27. Now I divide both sides by 3, and so now I have the x squared term isolated, and it's equal to 9. Then I'm going to take the square root of each side. Oops. Let me fix that real quick. Take square root of each side of the equation. And so I'd have x on this side, and here remember I have to bring in the plus or minus and square root of 9, and so it's going to tell me that x is equal to plus or minus 3. And so the problems are quite simple to solve because we don't have this bx term. And so this method, it just takes a couple steps and we can get our answer. If we're solving and we have x squared equal to 9, and since 9 is greater than 0, we know then that we're going to have, since 9 is greater than 0, then we will have 2 solutions, because we'll be able to take a square root of a positive number. If we have x squared equal to 0, then let me just take that out. Then we will have only one solution. Okay, I'm going to get my eraser real quick and take that out. Okay. And if we have x squared less than 0, then we will have no real solutions. So if you look back on what we did on the last section, in those notes we were looking at the graph and where the graph would be located so that we would have no real solutions or no x-intercepts, and it was situated so it's never going to cross the x-axis. It wouldn't matter if it faced up or down, it's just not going to cross the x-axis. Here, if this is a negative number, then when we go to take the square root of both sides, we're taking the square root of a negative number, and there is no real solution in that case. There are solutions if we get to the complex numbers, but not in our real number system. Okay, I hope this has helped you, and I will see you in class soon. Bye-bye.